All right, Trig section 1.2 is it's called the unit circle, and we've already done a lot of stuff on our unit circle. We made one already. I've already shown you that from 0 degrees to 180 degrees is pi radians, because it's exactly 3.14 radius or radii that would get you there. But now we want to analyze a little bit more some of the actual trig functions that we could actually see on the unit circle. Some of the trig functions. Okay, so want to start with reminding ourselves what sine means. What ratio does sine mean? So, SOH. Opposite over hypotenuse. So write that down where we put sine, opposite over hypotenuse. Cosine is cos, C-A-H. That would be adjacent over hypotenuse. Tangent is TOA, T-O-A. Opposite over adjacent. Now we have three new ones. Cotangent, secant, and cosecant. Three new ones for us. Cotangent is going to match up with tangent, and it's going to be its reciprocal. So if tangent is opposite over adjacent, cotangent is going to be adjacent over opposite. So it's the reciprocal of the tangent. Those two are connected. They're reciprocals of each other. Secant is going to be connected to the cosine. So it's the reciprocal of cosine. If cosine is adjacent over hypotenuse, secant has to be hypotenuse over adjacent. Okay, so these two are reciprocals. That means that cosecant is going to match up with sine, and it's going to be the reciprocal of our sine. So opposite over hypotenuse is going to switch around and be hypotenuse over opposite. So you've got three now extra ones, and they match up with our three other ones. They're just reciprocal. Yeah. They're the same, negatives and positives. Yeah, but right now they're just flip them over. That's all we need to know. They flip over. Okay, so there is the first couple of trig functions. Now let's take a look at, well, before I go there, the sine is going to need a cofunction because it doesn't have a co in front of it, right? So the sine is going to go with the cosecant. You just need to remember you need to have a cofunction in one of your pairs. Cosine already has a co in front of it, right? It's already a cofunction, so it needs to have secant. And then tangent needs to have its cotangent. Each one needs a cofunction. So that's the way I usually use to remember them. Because sometimes I always forget, which one does sine? Does sine go with secant? Does sine and secant sound alike? But sine has to go with cosecant because it needs a cofunction to go with it. Now let's look at our unit circle, and let's look at where I'm going to put angle T. So let's click there, and you can see that I just made myself a triangle, and I've got angle T right here. Now notice how I put my X value here on the bottom. I've got my Y value going up the side here. My radius is always 1. The unit circle, so my radius is 1. We want to analyze. Now, do you remember what triangle this is right here? Okay, where's the 30-degree angle? This is the 30. Remember, because when I come up to here, this angle right from here to here is where my 30-degree angle was. This is a 30-degree line that this angle is making down here where T is. T is my 30. This angle up here has to be 60 degrees. This 30 degrees represents the 30-degree line that this is making. Then we got our 45 degrees, we got our 60 degrees. So this angle right here is my 30-degree angle. Let's look at the sine value here. Let's look at the sine of T. Sine is opposite over hypotenuse, SOH. So my opposite would be my Y value. My hypotenuse is 1. So let's put that right here, Y divided by 1, or Y over 1. What is Y divided by 1? Just Y. So an easy way to remember what the sine is on your unit circle is just find the Y value. So if I'm looking right now at this angle, my sine is going to be my Y value. What is the Y coordinate at that point? Y coordinate is what? 1/2. So my sine is actually going to be 1/2. Now let's look at our calculators. Grab your calculator, and if you took one of mine, you're going to need to switch it out of radian mode into degree mode. So you're going to see it was probably in radians. You're going to need to hit the DRG button, go over to degrees, and hit enter or equal, and you'll be in degree mode. Okay, so you'll have degree mode. Yes. Because you see this coordinate right here, which is radical 3/2 comma 1/2. The 1/2 is my y value. So the sine is 1/2. Now look at your calculator, hit the sine button, and hit 30 degrees, and hit equal. 0.5. So the calculator knew that we were at this point. The calculator knew that the sine was the y value, which is exactly 1/2 or 0.5. So the sine is always going to be your y value on the unit circle. So if I was to say, what's the sine of 60 degrees? Don't put it in your calculator, look on your chart. 60 degrees, there's my coordinate. What's the sine going to be? Radical 3/2. Okay, do me a favor, on your calculator, put radical 3 in and divide it by 2. See what comes out as a decimal. Do radical 3 divided by 2 and hit equal. You get 0.866? Now put in sine of 60 and see if the calculator knew that this was going to be 0.866. Sine of 60, you should get your 0.866. The sine is always going to be your y value on the unit circle. So if you got a coordinate on your unit circle and you want to know what the sine is, sine of pi/4 is going to be that y value. What's the sine of pi? You can put it in your calculator, it's not going to come out because it's radians. You're in degrees. You put in pi in your calculator right now, you're going to be putting sine of 3.14. That's not what you want. What is the sine? Look at my chart. What is the sine of pi? What's the y coordinate where pi is? 0. 0 is going to be the sine. Now, if you put in sine of 180 right now, put in sine of 180, you're going to get 0 because that's your y coordinate. Okay, sine of 180 is 0. Now let's look at cosine. Cosine is adjacent over hypotenuse. So my adjacent side is x, my hypotenuse is 1. So I'm going to put x over 1, which equals x. So my x coordinate is right there. It's going to be radical 3/2. Remember what radical 3/2 was in our calculator when we typed it in? It was 0.866. If you put in the cosine of 30 degrees on your calculator, cosine of 30, you should get your 0.866 because your cosine is always your x value. X value. Now what about tangent? Tangent. TOA. T-O-A. SOHCAHTOA. Opposite. What's the opposite of my triangle? Y is across from it. What's my adjacent? X, so it's going to be y over x. Now, y over x is going to be a little tricky for us to find. Y value is your 1/2. Your x value is your radical 3/2. Could I divide those two? Could I divide those two? Okay, try it on your calculator. Put 1/2 or 0.5 divided by, you remember this was 0.866? So put 0.5 divided by 0.866. See what comes out on your calculator. Okay, 0.577? Okay, so now go to your tangent and hit tangent of 30 degrees because that's what that angle is. Tangent at 30, the calculator knew that you had to do x, you had to do y over x. It knew how to divide those two. So the tangent of 30 is going to be your 0.577. Now, what would we get if we actually left it as a radical here? Do we know how to divide fractions?
Yeah.
Okay, let me bring this up here. It's going to be 1/2 times, and I'm going to switch this around. What's it going to be? 2 over radical 3. So I'm going to cancel those out. I'm going to get 1 over radical 3. Is that good? Not done. Can't have a radical on the bottom. So multiply by the radical 3's. Your answer is actually radical 3/3. So right here for tangent, you're going to put radical 3 over 3. Now, if you did radical 3 divided by 3 in your calculator, you're going to get the 0.57 again. It's going to come out the same. So that would be your tangent. Now, your cotangent is the reciprocal of tangent. So we're going to put x over y. The secant is the reciprocal of cosine, so it's going to be 1 over x. And then the cosecant is reciprocal of the sine, which is 1 over y. And we'll figure out what those three are on the next slide. So we'll just leave it as those right now. These three are going to be the most important three that we'll need, so put those on there. So that's kind of how the unit circle works with sine and cosine. Your sine is your y value. Your cosine is always your x value. The tangent is always your y over your x value. And you can see it on calculator, you can see it on the board. Okay, so let's look at the next one here. Okay, pi over 6, that's what we were just looking at, right? So plug in the point was radical 3 over 2, comma 1/2. That was the point we were just looking at. What did we tell you? What did we say the sign was? It's right on your paper. Right as a half, because it was the y value, so it's 1/2. What was the cosine again? Radical 3 over 2, because it was your x value. What was the tangent? We already figured that one out. It was radical 3 over 3. It was the 0.57 number. Now, cosecant is the reciprocal of the sine. So let's flip that one over. You're going to get 2 over 1, which is just 2. The cosine is the reciprocal of the secant is the reciprocal of cosine. So I need to fix that because radical 3 on the bottom doesn't work. So yeah, let's multiply by the radical 3's. You're going to get 2 radical 3 over 3. Cotangent. Do you remember tangent was 1 over radical 3? And we had to fix that? This was actually, let me erase that for a second. Let me put that over here. Tangent was 1 over radical 3, and then we fixed it and got this right there. Rather than flipping this one around and then fixing it again, why don't we just flip this one around? That's going to give me radical 3 over 1, which is just radical 3. So your cotangent there would just simply be radical 3. So I took my radian point here, found my coordinate, and then found all 6 trig functions at that point. Now let's find out where 5 pi over 4 is on your unit circle. It's on the paper right above that. Where's 5 pi over 4? 5 pi over 4. Give me the coordinate for 5 pi over 4. Negative radical 2 over 2 and another negative radical 2 over 2. So you got the same exact x and y value. So what is my sine at this angle right here? What's the y value? It's going to be the y value, which is negative radical 2 over 2. What's the cosine? The x value, which is the same exact thing, negative radical 2 over 2. What's my tangent? Y over x. What's radical 2 over 2 over another radical 2 over 2? Negative. It's going to be a 1. The tangent's just going to be a positive 1. A negative divided by a negative would be a positive. When you have the same thing on top and bottom, it's always 1. Cosecant right here is the reciprocal of my sine. So it's going to be negative 2 over radical 2. But I need to fix that, so I need to multiply by the radical 2's. Negative 2 radical 2 over 2. And you can cross that out, so it's just negative radical 2. Do I need to do all that work again for secant? No, because it's the exact same thing. Sine and cosine were the same, so it's going to be negative radical 2. What's cotangent? Still 1. You're right. When you flip 1 around, you're going to still get a 1. Reciprocal of 1 is 1. Find on your unit circle where we have 0 degrees or 0 radians. Okay, that's the point 1, 0. Okay, look on your circle. You see where 0, where it starts, is the point 1, 0. What's my sine at that angle? Sine of 0. 0. If you plug it into your calculator right now and you hit sine of 0, it'll come out 0. So that'll come out as a 0. Now what's the cosine at 0? 1. Try it in your calculator. Just put in cosine 0 and see if a 1 comes out. Cosine of 0 should come out as a 1 because it's going to be a 1. It's going to be the y value. It's going to be a 1 over 1, which is 1. The tangent of 0. 0 over 1, which is 0. Cosecant at 0 degrees. If I flip this around, if I make it a fraction and flip it around, I get 1 over 0. You can't have 1 over 0. So yeah, undefined is right. You can put UND period or you can write it out, undefined. You can't have a 1 over 0, so it's got to be undefined. Secant of there would be a 1 because when you flip around to 1, you're going to get a 1. Tangent, cotangent at t, cotangent at 0 is also undefined. You can't have a cotangent there as well because you can't have a 1 over 0. Where's pi on our unit circle? At 180, what's the coordinate? Negative 1, 0. So the sine of pi, 0 is right. It's your y value. The cosine at pi, negative 1. Tangent at pi, 0 divided by negative 1 is 0. Cosecant at pi, undefined. You cannot have a 1 over a 0. Secant at pi is negative 1 still. Negative 1 over 1, when you flip it, is still negative 1. And then cotangent at pi is undefined. Can't have a cotangent there because it would be a negative 1 over 0. Can't have a 0 on the bottom. So those are, when it asks you to find the 6 trig functions at an angle, if it's on your unit circle, makes your life a lot easier because you can just know the y value is your sine and the x value is your cosine. And it makes your life a lot quicker. Okay, let's try this one. What about a negative angle? Negative pi over 3. Look at either your unit circle or the unit circle on the other side of the paper and see if you can find a coordinate for negative pi over 3. Now, on your own unit circle, you guys put all the negatives in, right? On that one, the negatives aren't there. So what would actually be the angle on our unit circle that would be the same as negative pi over 3? Yeah, but what's the radian at that point? What's the same angle as negative pi over 3? 5 pi over 3. If you look at 5 pi over 3, which would be down in this area down here, that's just like you went down negative 1 pi over 3. Because if I added 6 pi over 3 to this, to one circle, my coterminal angle would be 5 pi over 3. What's the coordinate that gets me there? 1/2, comma, negative radical 3 over 2. So what's my sine of that angle right there? Negative radical 3 over 2. My y value is my sine. What's my cosine? 1/2. It's my x value. What's my tangent? It's the y value, negative radical 3 over 2, divided by, I'm going to change it to times, and I'm going to flip around my cosine, because it's divided by the cosine. I'm going to multiply by the reciprocal. I'm going to cross cancel these out. What's my tangent going to be? Negative radical 3 over 1, which is just negative radical 3 is my tangent. Okay, let's go back up to cosecant. From right here over to, from sine over to cosecant. So I'm going to get a negative 2 over radical 3. Let's get rid of that radical from the bottom. You're going to get negative 2 radical 3 over 3 is my cosecant. What is my secant? Flip around a half, you're going to get a 2. Cotangent is going to be negative 1 over radical 3. So you're going to need to multiply by the radical 3's. You're going to get negative radical 3 over 3 is my cotangent. So that's the 6 trig functions, even at a negative radian angle, because we know that it's actually going to be at this coordinate for that negative angle. All right, domain of sine and cosine. There's one little mistake I need you to fix on your note. I put y coordinate twice. You need to fix this to x coordinate right there. So change that to x. It says since sine represents the y coordinate and cosine represents the x coordinate, they must be between -1 and 1. Look at your unit circle right here. Look at all the y values. The y values, how high does the y value go? Only to 1. Doesn't go past it. How low does the y value go? Only to -1. Never goes past it. The two x values never go beyond 1 and -1. So your sine and your cosine, whenever you put them into your calculator, will always be between 1 and -1. You can't have anything higher or lower than that, because that's how far you could go on your unit circle. So that's the domain of sine and cosine. Now tangent, cotangent, secant, cosecant, those can be more than 1. Here's an example of that right now. Look at this right here. Secant was 2, because we took the reciprocal of my cosine. Cosine has to be less than 1, right? Or less than -1. So that was a half, but the secant can be higher. So the domain of the sine and the cosine has to be between 1 and -1, always. All right, what about using a period? What if we want the sine of 13 pi over 6 right here, but it's not on my unit circle anywhere, so I can't find the coordinate? Could we do that? Could we figure it out? Yeah. Okay, so let's see if we can do that. Let's take my 13 pi over 6 and subtract 2 pi. Why would I do that? Because that's a rotation. That would put me back on the circle. Because right now, this 13 pi over 6 means I started here, and I went around past the starting point again. So I'm going to come back around to see where I would have been. So I'm going to subtract 2 pi, which I'm going to change to 12 pi over 6. Everybody okay with me changing it to that so I have a common denominator? Okay, so let's get rid of this 2 pi. We don't need that. 13 pi over 6 minus 12 pi over 6 is just pi over 6. Okay, what's my coordinate at just pi over 6? Okay, right here is my coordinate, radical 3 over 2.5. So what's my sine of 13 pi over 6? Because 13 pi over 6 would be from this angle to this angle going around once. So that means if it stops here, we're using this coordinate. Okay, if I would have just gone to pi over 6, it would have still been that same coordinate. You would have still had the same sine and the same cosine and so on. So what is the sine of 13 pi over 6? It's going to be a half. I want you to test that one on your calculator. So here's what I want you to do. What is 13 pi over 6? Is that in degrees or radians? Radians. So I want you to take your calculator and change it to radian mode. So on this calculator right here, you have one of these. You have to turn it back on and hit the DRG button. You have to move it to radian, R-A-D, and hit equal or enter. That'll put you in radian mode. Okay, so we good there? If you got a different calculator, you got to find the mode and you got to find radian. If you can't, don't worry about it right now. I think the iPhone, it has an RAD button for radians. So that kind of goes quickly, but it's up to you if you want to use whatever. I just want you to test this. Okay, in your calculator, I want you to hit the sign, and you get a parentheses like this. I want you to put the 13 pi slash 6 all inside the parentheses. The whole thing inside parentheses. And hit equal. And hopefully on your calculator, it comes out as 0.5. Yeah. If it's in radian mode and you put it in this way, you're going to get that 0.5. So that's how it works with radian mode. You can plug in radian. So let's try the second one here. You have your radian mode, right? So -7 pi over 2, and we want the cosine. So in your calculator, put cosine, In the parenthesis, put negative 7 pi slash 2, end the parentheses, and see what comes out on your calculator. Cosine of negative 7 pi over 2. 0? Okay, let's put a 0 here. Now let's see if that works from our unit circle. Where's negative 7 pi over 2 on here? Right now it's not on there anywhere, is it? Let's go ahead and add a rotation. So let me get rid of this equal sign here. And we're going to add 4 pi over 2. Everybody okay with 4 pi over 2? Because that's the same as 2 pi? Okay, so what's negative 7 pi over 2 plus positive 4 pi over 2? Negative 3 pi over 2. Is that on my unit circle? It's on the one that you guys made, because you guys put in the negative angles, right? Negative 3 pi over 2 would start here. This is 1 pi over 2 negative. This is negative 2 pi over 2, which is negative pi. This right here is negative 3 pi over 2. So starting here and ending here would be my negative 3 pi over 2. What's my coordinate up there? 0, 1. What's my x value? 0. We already knew it was going to come out 0 because we put it in our calculator and 0 came out. That's why the 0 came out, because it's this coordinate and the x value is your cosine. So this came out to be a 0 right there. Cosine of negative 7 pi over 2 is the same as cosine of 90 degrees, or positive pi over 2. It's all going to be 0 there. All right, we have one last slide. It's pretty quick. It's just a calculator one. So you guys good here? Okay, so using a calculator in radian mode, you should already be in radian mode, hopefully. I want you to plug in your calculator. Now, before we do it, let's look at the unit circle. Where is 2 pi over 3 on your unit circle? 2 pi over 3 is what coordinate? Negative 1/2, comma, radical 3 over 2. So what will the sine of 2 pi over 3 equal on my unit circle? Which one is the sine here? The x or the y? The y. So it's going to be the radical 3 over 2, which is the 0.866, right? Yes. Now in your calculator, put sine, parentheses, you're going to put the 2 pi slash 3 all in parentheses, and see if you get the 0.866 to come out on your calculator. Did it work? Yes, it works. If you put it in radian mode, you don't technically have to go into your unit circle. You could use your calculators and get the decimals. The decimals will come out right away. Now, what about using a calculator to find cotangent? Because I don't see a cotangent button on our calculator. How do I get a cotangent to come out on there? What's the cotangent the reciprocal of? Tangent. So here's what I want you to do in your calculator. I want you to put in 1 divided by tangent of 1.5. You should be in radian mode. And hit equals. Okay, so what is it? 0.0709. That's what should come out on your calculator when you get, that's the cotangent. Now I put a little symbol down here that the tangent is the same as 1 over cotangent. You could also put that cotangent is the same as 1 over tangent, because they're reciprocals of each other. So in my calculator I need to put like 1 over tangent to get the cotangent to come out. Let me see if you can figure out what this one is. Let's go with secant of pi radians. See if you can get that to come out on your calculator. Tell me what you get. Secant of pi radians. Secant of pi radians. What did you guys get? -1. Did you put in a 1 divided by cosine of pi? So that's how you would get secant. You put in 1 divided by cosine, and your x value at that pi was -1, so your so it would be a -1 then. That's what would come out. All right, so you're going to have a few on your homework that are just calculator problems. So those, there's not any work to show. All you got to do is write the problem, do it in your calculator, put the answer. The odd ones you always check in the back of the book. Don't forget to do that.